Hey, everybody. I weigh about 155 pounds. But what does a pound mean? What really is 1 pound? Who decides how much a pound actually weighs? And when I say I'm 155 of those, well, does that mean the same thing to me that it means to you or to everyone else? There's actually a physical object used to determine the weight of the kilogram and therefore the pound. And it's this object right here. This is the world's roundest object. And they made this object to be perfectly spherical, to be a certain number of atoms as closely as possible, to have an object define what a kilogram is.
Good morning, CT students. Just a friendly reminder that you can start heading to class now. The doors are open for you to head to your 1A class. Thank you.
So outside of this object, there's not an other object in this world that defines the pound aside from this. And basically, if this object were to change, then our definition of the pound would also change. That's just one interesting aspect of units that we're going to start thinking about, learning about, and being comfortable with. The units that we use in class are all defined in some way. Now, one first concept that we want to take a look at when we talk about measurements and units is what's the difference between accuracy and precision. I have two rulers here. The first ruler only has marks. Let's say these are centimeters, and so it has marks for each centimeter. Here at the bottom on ruler B, we have 10 marks within each centimeter. What's the difference between these two rulers? Well, we would call both of these accurate. They're both accurate, which is how close something is to the true value. And so both of these are 7 centimeters. Both of these are 6 centimeters. There's nothing inaccurate about these markings right here. However, we see that in between each centimeter here, we have more markings. And these markings allow us to get a more fine-grained measurement of how long something is. And because this ruler has more markings, this ruler is more precise. What do I mean by a fine-grained measurement? Well, let's take a look at how each of these rulers would measure this object. For ruler A, I see that the object is in between 4 and 5 centimeters. Now, I don't know if it's 4.5, 4.6. I have to estimate. And using an estimate, I would say that this is 4 point, let's say, 8 centimeters. This last digit right here, this 0.8, is an estimated digit. And due to this ruler not having any markings, that's the only digit that I can estimate. I can't go any further. I can't say that it's 4.80 because that would mean that I would have markings to tell me that it's in between 4.8 and 4.9. I don't have those markings. I only have 4 and 5, and my estimate is going to be in between 4 and 5. Therefore, I can estimate 4.8 and not 4.80. Down here, though, I see that my object is in between these two markings, in between 4.8 and 4.9. By the way, there's 10 markings here. So this marking is 4.1, 4.2, 4.3, 4.4, 4.5, 4.6, 4.7. I know that it's in between 4.8 and 4.9. So I can estimate one more digit, and I'm going to say it's 4.82. I know that because I know this number is in between 4.8 and 4.9.
Start heading to class, your 1A class today. Have a great day.
So, because this ruler B has more markings, I can estimate one more digit. And the fact that it has more digits means that it's more precise. So if you wanted a definition for how we can tell if something is more precise, if a measurement has more digits, it is more precise. Let's do another example. Here we have 3 rulers. Again, all 3 of these rulers are equal in accuracy. They're all correctly measuring 100 centimeters. However, this one has more markings, so this one is the most precise. And let's take a look at how we would record each of these measurements. Again, we can estimate one digit. For this first one here, we know that the item is in between 0 and 100 centimeters. So we can estimate that this is something probably about 20 centimeters. This right here is the estimated digit. I estimated this too. Down below, here we have more markings at each 10 centimeter mark. Here I know now it's in between 20 and 30. So I'm going to estimate this somewhere between 20 and 30. Let's just say 22 centimeters. This right here is the estimated digit. I know it's in between 20 and 30, so this first 2 is not estimated. The second digit is what's estimated. Now, when I get down to here, I know I'm in between 22.2 and 22.3. And so I'm going to estimate one digit and say this is 22.25. This digit is the estimated digit. Let me just say briefly about decimals. If I have 22.2 and 22.3, the numbers in between these numbers are 22.21, 22.22, 22.23, all the way on till 22.29, and then what comes after that is 22.3. Similarly, 22.2 is equal to 22.20, and 22.3 is equal to 22.30. It's just that these numbers right here are more precise, and they have a higher level of precision. Let me show you an example of what that would look like. Let's say my object, instead of being at 22.5, went all the way to this mark right here and is right on the line. In that case, instead of 22.5, I could say it's 22.30. This 0 is the estimated digit. And it's like I'm estimating that it falls right on that line. So again, if it went all the way to the line, it would be 22.30. And as you can see, the number of digits that I write show me how precise my instrument is. The more digits that I have, the more precise the measurement. Now, let's go ahead and do some practice. Check on Schoology for the link to the practice that's associated with this video.